So now we are looking at chapter 4. So that is the name of the chapter. It's called Time Value of Money. Time Value of Money. And we start with the introduction. Introduction. And you write that a shilling today is worth more. A shilling today is worth more than a shilling tomorrow. A shilling today is worth more than a shilling tomorrow. Full stop. The future value, into brackets FV, the future value into brackets FV is the value at some time. Is the value at some time in the future. Is the value at some time in the future of a present sum. Of a present sum or series of money. Sum or series of money. Present sum or series of money. Full stop. The present value into brackets PV, the present value into brackets PV is the current value, of a future sum or series of money. Of a future sum or series of money. Of a future sum or series of money. Full stop. Another point is simple interest is the interest paid. Simple interest. Simple interest is the interest paid only on the original amount.
Pardon, Madam. We lost you there for a second.
Okay. I've said simple interest. Simple interest is the interest paid or earned. Can also add that. Is the interest paid or earned only on the original amount. Only on the original amount. On the original amount, full stop. It's computed as interest is equals to P R T out of 100. It's computed as I is equals to PLT out of 100. The person who has joined, good evening.
Good evening.
Ni nani huyo? Ni Naomi.
Naomi Goire.
Oh, imetoa admin, haijatoa jina yako. That's right. Okay, so the formula is I is equals to PLT out of 100, where I is simple interest, P is the principal or original amount, R is the interest rate, and T is the time or periods. The time or periods. That's called simple interest. I is equals to simple interest. P is called principal or original amount. R is called interest rate. T is the time or periods. Okay, another point is this. Compound interest is the interest paid on the original amount, and any interest paid again. Full stop. It is computed as interest is equals to P, sorry, not P. Interest is equals to A minus P. Interest is equals to A minus P, where A is equal to P 1 plus R, you raise power N. You raised power N. Now, A is the amount received. N is the periods. Maybe I needed to say R is the annual interest rate. Annual interest rates. Annual interest rates. Annual interest rates. Another sentence, you write, if compounding is done more than once, if compounding is done more than once in a year, if compounding is done more than once in a year, you write this formula. A is equals to P, 1 plus R out of M raised power Mn A is equals to P, 1 plus R out of M raised power Mn, where M is the number of compoundings in a year. The number of compoundings in a year. The number of compoundings in a year. Another sentence is, if compounding is done continuously, if compounding is done continuously, if compounding is done continuously, A equals P, let me write it somewhere different. A equals P e raised power R n. Where E is 2.7182. E is 2.7. Okay. Another point is the process of getting the future value. The process of getting the future value is known as compounding. It's known as compounding. It's known as compounding. I would like you to write this equation. FVN, FV, that's the future value of the present amount, P naught. P naught means the current amount. You take 1 plus R, you raise power N. You raise power N. This one, it also becomes P naught times the future value interest factor. Future value interest factor, FVIF. So hii itakuwa lugha yetu sasa. The F, although the one we use more is PVIF. At KN. KN. Another point is the process of finding the present value. The process of finding the present value is called discounting. Is called discounting. It's called discounting. Then you write this value, PVN is equals to the PN, or the future value, one plus R, you raise power minus N, which is equals to PN multiplied by PVIF, KN, PVIF, KN. Yeah, so that is how we can begin the topic. And there are key points that we have mentioned here. When we talk of the time value of money, we are trying to look at, does passage of time affect the value of money? And when we talk about value of money, we are looking at what the money can get, what the money can buy. So if my 10 shillings today can buy this pen, 1 year after today, can the same 10 shillings buy this pen? If yes, it means time has no impact on the money. But if the answer is no, it means that the passage of time from today to next year has created a change in the value for money. That today I can buy this pen with only 10 shillings. But 1 year after today, when I go to the shop, I will be told, add some more money, 10 bob haitoshi. So that is the concept. We are simply saying that passage of time affects the value of money. That's what we call time value of money. Now, in that language then, we have the money today and the money tomorrow. And the general rule in finance world is that a shilling today is better than a shilling tomorrow. If I have your money I would rather you come for it, or you should rather come for it today, not tomorrow. If you have my money, I would rather you pay me today, not tomorrow. And the main reason why a sharing today is better than tomorrow is because tomorrow has what we call uncertainty. Later on, we'll be discussing this. Uncertainty means we are not sure kama utapewa. I'm not sure. Now, the value of money today is what we are calling the present value. The value of money tomorrow is what we are calling the future value. If you want to know the sharing that I have today, it will be worth how much tomorrow. That process is called compounding. If you want to know the future value of the present cash, it's compounding. And we have talked about compound interests here. Where? Here. And you can see the formula is basically the same. Then tumeongeza hii inaitwa future value interest factor, because there are two ways of going about it. You can either be using the formula, or you can be reading these ones from the table. For me, because my background is mathematics, you will find I prefer using the formula more than reading the table. But I'll be showing you also how to read the table. Higher. If you want to know the present value of some money in future, the present value of some money in future, that process is called discounting. And this is the formula we use. The difference between the two formulas is that this n here is negative when you're discounting, and here it is positive when you are compounding. When you are compounding. Because compounding, you can actually argue like this, for cramming purposes. Compounding ni kuongeza, so it is positive. Discounting ni kupunguza, so it's negative. We have two types of interests. Simple interest, hii unajua kutoka class 7 mathematics. Simple interest, PLT. That's where only the original earns interest. We have compound. This is where the original plus the interest, the earn interest. So basically, that gives us an overview. And this area is very, very important. When you are in the world of finance, this area is very, very important. Compounding, discounting, compounding, discounting. And something else that I was almost forgetting is that when we are talking about money, we are talking of a sum. Sum is a single amount, or we are talking of series. Series means several amounts or different amounts. As in, for example, if we are talking of 100,000 in 5 years, unaweza ambiwa miaka 5 ikiisha utapewa 100,000 ikiwa together. That's called lump sum. Wende upewe 100,000. Alternatively, wabiwe badala ya tukupatie hiyo 100,000, every year tutakuwa tunakupea 20. So by the time tufunge mwaka wa 5, ukimultiply by hii, you have your 100. So in this language, we are either talking of the sum or series. And there is another term we call annuity. But before I introduce annuity, I want us to do a simple illustration. But annuity is still this language here. So andika illustration 1. Illustration 1. And we write, an investor has invested Kenya shillings. An investor has invested Kenya shillings 650,000. 650,000 at an annual rate of 15%. At an annual rate of 15%, compounded annually. Compounded annually. Full stop. Determine the future value of the investment. Determine the future value of the investment after 3 years. Future value of the investment after 3 years. So this is what we are calling compounding, annual compounding. So tumesema amount will be given as P 1 plus R you raise power N. So this person has invested 650,000 and the interest rate is 15% for 3 years. So solve that and give me the answer. Solve that. Give me the answer. I'm waiting for the answer.
So 988,568.75.
Okay, 9, maybe you can type 988 568.75. The other, someone else to confirm. Make sure you said your answer. Sasa tumeingia kwa mahesabu. And the only way I can know we are together is when you said your answer. So Dennis has already given us 988. Yes, Janet. So the answer from Janet and Dennis, they agree. And therefore we take that. Okay. Higher. So that is very simple. Remember, we are just at the introductory. So I think that is good. Now, the next thing that I want us to mention is called annuity. Annuity. And we write that an annuity is a series of payments. An annuity is a series of payments or receipts of equal amount, or receipts of equal amount. Full stop. There are two types. There are two types. One is ordinary annuity, and we can explain it. Ordinary annuity. This is where cash flow occurs at the end of each period. This is where cash flow occurs at the end of each period. Cash flow occurs at the end of each period. Full stop. And we write this formula. The future value of ordinary annuity, the future value of ordinary annuity is equals to A 1 plus R raised power N U minus 1 to divide by that's the formula. Or if you want to write in terms of the tables, the language here table, it is 8 times the future value interest factor for annuity at R% and N. So this means the future value interest factor for annuity. I'm not keen to write that, the meanings, because hii ndio itakuwa lugha almost every lesson. So taizoea kabisa. Maybe what we need to specify is where A is the annuity amount. Annuity amount. The present value of ordinary annuity is A 1 minus 1 plus R, you raise power minus N, you divide by R. If you want to get the present value, formula inapiduka hivyo. So I believe you have copied. So number 2 is called annuity due. Annuity due. Annuity due. And we write that this is where cash flow occur. Cash flow occur at the beginning. cash flow occur at the beginning of each period. Cash flow occur at the beginning of each period. So the future value of that annuity is A 1 plus R raised power n minus 1 you divide by R, divide by R, then you multiply by 1 plus R. Multiply by 1 plus R. Yeah, so that is what we call annuity. As I said earlier, you could have a lump sum or you could have a series. A lump sum or a series. So if it is a series and the amounts are equal, we call them annuity or annuity. We have two types depending on when each amount is received. So if the amount is received at the end of the period, that's called ordinary. Na hii ndio tutakuwa tunaona sana. That's actually why it's called ordinary. This one is very rare, very, very rare. It is the one that is received in advance, or at the beginning of the period. Yeah, the beginning of the period. So let's have another illustration or example. Example. And you write, an employee has decided to deposit. An employee has decided to deposit Kenya shillings 1,500,000 per year. 1,500,000 per year. Per year into a retirement benefit scheme. Into a retirement benefit scheme for the next 6 years. A retirement benefit scheme for the next 6 years. Beginning at the end of the current year. Beginning at the end of the current year. Full stop. Interest rate is expected to remain constant. Interest rate is expected to remain constant at 12% per year. At 12% per year. %12 per year. Full stop. Determine the lump sum amount. Determine the lump sum amount at the end of the 6-year period. Determine the lump sum amount at the end of the 6-year period. So huyo mtu ameamua every year atakuwa anaweka 1.5 million for 6 years. So kama hakungekuwa na hii lugha ya compounding, you would already have said the 1.5 times 6. That's around 9 million. Yeah. Hiyo ndio atakuwa ameweka. But because a sharing today is not the same as a sharing tomorrow, we have then to do compounding. And there are two ways in which we can treat this question. The first way in our solution is when we treat it as ordinary annuity. If you are treating it as ordinary annuity, that means atakuwa anaweka beginning of the end of this year. Tunatumia hii formula hii tu. So the future value of that ordinary annuity, it will be 1,500,000. Hiyo ndio anaweka 1,500,000 times 1 plus 0.12 you raised power 6, because anaweka for 6 years. Then you subtract 1. After you subtract 1, you divide by 0.12. That way. So work out that, na kila mtu anitumie jibu lake. Work out that. Very simple. Huh? Where's the answer? Yes, Cynthia. Good. The others? Make sure you said your answer. Yes, Dennis. Said your answer. Yako ndio tunangoja. Yes, Janet. Naomi. Okay, so if it's the same, then that's good. So the same answer is 12,172,783.06. Yeah, so you can see now because of the time value factor, badala ya kupata ile 9 million alikuwa ameweka, atapata ikiwa 12. Atapata ikiwa 12, imepanda because the value will have changed. Yeah. So the second way is when you look at it as annuity due. Annuity due. Annuity due. So every OA is 1,500,000. 1 plus 0.12 raised power 6 minus 1, you divide by 0.12, then you multiply by 1 plus 0.12. So here, actually, it is just this answer. You multiply by 0.12, 1.12. So you just get that answer, this one, multiplied by 1.12. Tell me what is the answer. Uh-huh. 30 million is from Dennis. Yes, that is Dennis. The others? Yes, same. That is that 10 million. 633. 633. 517.59. The reason as to why the annuity due is more, it is because the amount yenye imewekwa saa hii leo imeanza ku count, ku earn interest today. Yeah. But in the ordinary, that amount ikiwekwa end of the year, it will not have earned interest this year. So interest yake itakuwa kidogo. That's the reason why the annuity due inakuanga mingi. Haya. Kama tuko sawa up to that point, sema yes. If you are not okay, you can raise a question. Yes, Naomi. Cynthia. Janet. Yeah, then it's good. So we are good. Nasonga tu, building our case. Still, when in this language of annuity, growing annuity. Let me just call it that way. growing annuity. And we write that if the annuity amount is growing in perpetuity, if the annuity amount is growing in perpetuity, it's growing in perpetuity, colon, uandike hii formula. The present value is the annuity or 1 plus G, you divide by R minus G, and this one is given as A1 R minus G where A naught is annuity for the year just ended. For the year just ended. For the year just ended. G is constant growth rate. Constant growth rate. R is the required rate of return. Required rate of return or cost of capital. Or cost of capital. And A1 is the expected annuity. It's the expected annuity. It's the expected annuity. Then another point. If the annuity will grow over a defined period of time, if the annuity will grow over a defined period of time, PV, write this formula. PV is equals to A, is equals to A, 1 minus 1 plus G, which is divided by 1 plus R. Then this one, you raise it to power N. And then the whole of this, you divide by R minus G. That way. So we are saying there is a possibility that the annuity is growing. Kama hiyo case yenye tumedeal nayo, tumeambiwa that mzee or lady will be investing 1.5 per year. But kuna uwezekano as the years go by and by ataanza kuongeza. So hii mwaka ameweka 1.5, hiyo mwaka ingine aweke 1.6, hiyo mwaka ingine aweke maybe 1.9, hiyo ingine aweke 1 or rather 2 billion. Yeah, so if they are growing, then we need to see how do you get the future value? How do you get the present value of that amount? So if it is growing in perpetuity means we have no end. It is also called infinite. It is also called continuous. So when you see the word perpetuity, you see the word infinite, you see the word continuous, they mean the same thing. And something else that I also wanted to bring to attention is that these are, we are calling it the required rate of return. We are also calling it the cost of capital. And in the other formulas we have written, we also called it the rate of interest. So those are three names that go for this. You can call it the minimum required rate of return. Some people just call it required rate of return. You can also call it the cost of capital. And as you go by and by, you realize it is not only letter R that is used. There are times you use K. There are times you use K or any other alphabet. Bora utuambie hii letter nimetumia hapa imesimamia what. Good. Let's have an example to illustrate that. Let's have an example to illustrate that. And we write that a company whose cost of capital is 12% per year, a company whose cost of capital is 12% per year, paid a dividend per share, paid a dividend per share, DPS, paid a dividend per share of shillings 3.22 in the year ended, of shillings 3.22 in the year ended. In the year ended, full stop. These dividends are expected to increase. These dividends are expected to increase at a constant rate of 5%. At a constant rate of 5% during the next 6 years. During the next 6 years. Full stop. Determine the present value of these dividends. Determine the present value of these dividends. Determine the present value of these dividends. So in our solution here, in our solution, now we shall use this formula here because we know the periods. So we say the present value should be this dividend per share 3.22 times 1 minus 1 plus G. That is 1 plus 0.05. This one, first of all, you divide it by 1 plus R. R is R tumeambiwa ni 12%. Then you raise power 6. And then the whole of this you divide by R. That is 0.12, 0.05. So work out that. Pole pole unipatie jibu. See, Dennis has given. Someone else to tell us. The others. Okay, I can see all of us, we have gotten that 14. That's good. Aye. So that is when the annuity is growing. Something else still in the world of annuity is called differential annuity. Differential annuity. Differential annuities. And we write that these are different annuities. These are different annuities These are different annuities in different portions. In different portions. In different portions of a project's economic life. Of a project's economic life. Of a project's economic life. Full stop. They are discounted using differential discounting factors. Using differential discounting factors and then added together. To establish the total present value. Added together to establish the total present value of the cash flows. To establish the total present value of the cash flows. Yeah. So what we have looked at previously or so far as the annuities are concerned, we are saying that hiyo pesa inapokelewa every period in the same way. Kama ni hiyo tumesema 3.2, every year ni 3.2, 3.2. Ama ile tulisema 1.5. Then tukakuja tukasema it could also grow. Now we are in the third situation where throughout the whole period of the project or the whole period of the analysis, we have annuities, but they are different within some proportions of time. Like if this project is going to be there for 20 years, actually that's the example I want us to do here. Unapata the first 10 years, the annuity is the same. Then the next 7 years, the annuity is the same. The next 3 years, the annuity is also the same, but the 3 of them are different. So we want to see how do you discount such. So let's have a simple example. Simple example tuseme a 20 years project. 20 years project. A 20 years project is expected to generate the following annual cash flows. The following annual cash flows. The following annual cash flows. So we have the years and then annuities. Annuities. From year 1 to year 5. From year 1 to year 5, we have 450,000. Then from year 6 to 11, year 6 to 11, we have 720,000. And then from year 12 to 20, we have 1080,000. $1080,000. $1080,000. Then you write that the required down there, the required rate of return is 12%. The required rate of return is 12%. It's 12%. Full stop. Determine the present value of these cash flows. Determine the present value of these cash flows. And remember, when we say present value, we are simply saying ukiambiwa utakuwa unalipwa hizi pesa hivi, ama ulipwe yote saa hii, so saa hii utaitisha ngapi? That's the simple question. If you are given those two options, ulipwe saa hii lump sum, we usonge, ama ukuwa unalipwa na this pattern. Like now when people retire, unaweza ulizwa tukuhesabie pension yako yote tukulipe to once we uende, ama ungekuwa unataka kupokeanga every month. So saa hii ni ngapi utaitisha? That's what we are trying to find out. I hope you are really getting to interpret these things or to understand. Isikuwe tu ni mahesabu tu, but at least it's making sense, practical sense. Haya, so in the solution, I'm going to rub here so that I get enough space. We are going to have the solution in a tabular way. The solution. Our table will be divided into 4 columns. We have the years. We have the annuity. We have the discounting factor. And then we have the present value. Maybe if I put it, if this is A, the discounting factor is what I would call PVIFA. And then now here, this will be A times PVIFA. So what are 2 columns? These ones are not white. This one is not a white one, even this one. Ile utarau space a little bit wide ni hii, because hiyo itakuwa na 2 PVIFs. Hata hii si kubwa, it's just an answer. Remember, as I said earlier, instead of using the formula, you can just go to the table and you read the tables that have computed those things. So for the first phase, year 1 to 5, the amount is 450,000. 450,000. So the PVIF, sasa hii swali nataka kutumia table. So you'll say PVIFA at 12% for 5 years. For 5 years. So fungua your past papers, Fungua your past papers and go to page 3 of 103. Page 3 of 103. If you are there, ukifika hapo sema yes. Ndio nihakikishe zote tuko hapo. Yes, Janet. Yes, Naomi. Cynthia. Dennis, bado?
One minute. Umesema page 33 of 103?
Yeah, page 33, that is. Around there. You should see some tables there.
Yeah, found it.
Okay. So if we are all there, you can see we have 2 tables. The first one is on page 32. Actually, they are in the same page. Good. They're in the same page. So the first one, it is the present value for one shilling received at the end of n periods. So those ones we call the SIGO cash flows. The SIGO cash flows. And you can see the formula there, 1 plus R raised to power minus n. Hiyo ndio tuliandika ya kwanza, the discounting. So huwa inasomwa, you can see the period. Period ndio hizi zimewekwa kwa column 1, 2, 3 hivyo zimeteremka mpaka kwa 60. Alafu the interest rate unaziona, sorry, period zimewekwa kwa rows. Interest rate zimewekwa kwa columns 1, 2, 3 all the way to 36. Haya. The other one, the second table is now for an annuity. You can see the formula that we are using. Ndio hiyo. So we are going to look at this table. That's the table that we are going to read. So if you want to use the formula, and as I said, the formula is 1 minus 1 plus. Sasa kama hii R, kwanza niandike formula, raised power minus n, you divide by R. That is the formula for the annuity. So nikiambiwa nitafute ya 5 years, I simply come here and say 1 minus 1 plus 0.12 raised power minus 5. Then all these I divide by 0.12. Ebu jibu hiyo according to the formula. Yeah, 3.6048. If you write it in 4 decimals, it is 3.604. Now, if you want to see it from the tables, what you shall do, if you want to see it from the tables, kama table iko namna hii, utakuja hapa kwa year 5, alafu utafute 12% hapa, usome the value that is here at the intersection. That's how it's read. Unaangalia tu mwaka, ni period gani unataka, na the interest that you have there. Yeah. So myself, as I said, I think I'm biased because I'm used to computations. So you'll find me quite often using the formula than reading the table. But sasa najua I think now umeelewa how to read the table. So kama hii mambo ya formula hutaki, unaenda kwa table. So you don't have to memorize this formula. The table is there. Ile kitu tu unastahili kujua ni kwamba hii ni miaka ama the periods, na this is the interest rate. Sasa unasoma hiyo value iko hapo. Alafu ujue kuna hiyo table ya annuity na kuna hiyo table ya SIGO period. Yeah. So, having said that, now this one is 3.6048. So now multiply this 450,000 by this amount. Unipatie ndio tujue the present value. There's Naomi has already given the others. Make sure you said your answer. I always want to avoid being accused of moving with the fast runners. Wanafunzi wanaweza sema Kimani anatembea na mwenye anafanya haraka. So to avoid that, I like encouraging that unaweka your answer so that by the time we are moving, najua we are together. So ukishapata jibu yako usikuwa unangoja mtu, uko peke yako hapo. I mean uko peke yangu hapa. So just said. Yeah, usigoje. Yeah. Okay. So kama tumetuma hivyo, I can see is 1,622,160. 1,622,160. So that is the present value for the first 5 years. Then kuanzia year 6 to year 11. Kuanzia year 6 to year 11, the cash flow is 720. So what happens here now, because there are 2 periods, kwanza hiyo table yenye umeona huwa imepeanwa kutoka year 1 mpaka that year. Like now ukisoma ya 11 years imecapture kutoka mwaka ya kwanza mpaka 11 years. So hapo even this 5 is there. 5 is there by the time you come to 11. So tutachukua hiyo ya 11 which is total, then to subtract ile ya. I hope you are getting that. Ni kitu inakaanga kama hii. So hii ndio first year hapa. Na hii ni 5. Na hii ni 11. So tunataka hii ka space kamebaki hapa. Hapa ni 11. So if the whole of this is A, kuanzia hapa mpaka hapa 11. And this one kuanzia A to, 1 to 5 is B. Tunataka kujua C kutoka mwaka wa 6 kwenda hivyo. Then this will simply be C must be given as A, U minus B. Hii part ndio tuachiwe hii. That's how it's argued. Because the interest rates zimeanza hii mwaka ya kwanza mpaka huko. Yeah. So kama tumeelewa hiyo, then applying this, I will need to look for PVIFA at 12%, 11 years, I minus PVIFA at 12%, 5 years. 5 years. So nisomee hii ya 11 years. Oh. Naomi has already given me everything. 5.9377. And 3 point, sasa ndio ile tulikuwa nayo, 3.6048. And according to Naomi, the answer is 2.3329. So the others, are you in agreement? Yes, Cynthia. Yes, Dennis. Janet huko? Okay, sawa. Naona kama umenyamaza. So now multiply this 720. Multiply your 720 by this one. Aya, 1679, 688. 1679, 688. Aya, let's go now to the last phase. The last phase is from 12 to 20 years. Yes, Dennis. The cash flow is 1080. So here, the same concept. It is the PVIFA at 12% for 20 years. You minus the PVIFA at 12% for 11 years. So, sasa nisomea 20 years. Somea hii. $7.46. $9.4. You minus 5.9377. $1.5317. So multiply na 1080. $16.54, 236. So the present value, you just now add these three. You just add those three. And there now you have the present value. Ndio uweze kujibu ukiulizwa kama unataka saa hii. Nasema mimi nataka saa hii, munipatie ngapi? $4,956,000. $0.84. Yeah, so that is how you get or you deal with the annuity that is differentiated. The annuity that is differentiated. Okay. So if that is how, on your own, I would like you to attempt this question. The question of May 2018, question 4D. I would like you to attempt it. Then when we meet next, you'll give me the answer. Kama hii. You'll give me the answer. So sasa, I think umeona masomo yameanza na hatuna muda mrefu. Hatuna muda mrefu. This day si kama venye tulikuwa tunafunza 5 months. So sasa, I think next week ni but one ni June. So tutakuwa tumebakisha only 2 full months za kusoma. Na ndio tumeanza. So by that I want to tell you, don't pile these notes. Start reading as early as now. Start reading as early as now. Tukisoma kitu unaenda una-revise. By the next time we are coming for the next lesson, usha familiarize yourself kabisa na hizo zingine. Because time hakuna. Time hakuna na tuko na mambo mingi tunastahili kusoma. So do that for all the papers that you are sitting for. Don't pile. Otherwise, ukipile, utastukia time ndio hiyo inakaribia uanze kupanic. So I think with that, we can call it a lesson. Tutarajie Mungu akitujalia tupatane next time to pick up from there. So not unless anyone has any concern, we bring the class to an end at that juncture. Okay, thank you. Good night.